Hello everyone, today we will start third lesson from class 10 science 1. Okay, so this lesson is about chemical reactions and equation. So student, in this video we are going to discuss about chemical reactions and how to write the equations of particular chemical reactions. Okay. So let us first start with a chemical reaction. What is it? So students, some of the scientists of the 18th and 19th century, they carried out fundamental experiments on the chemical reactions, and they proved from their experiments that during the chemical reaction, composition of matter changes and that remains permanent. Okay, that means this type of a chemical reaction, these are the irreversible. Okay, and during physical change, so this was a chemical change. During physical change, only the state of matter changes and this change is temporary. So we will see some different examples about chemical reactions and physical reactions. So we will see how these reactions, chemical reactions are irreversible, and physical change are not reactions, physical change, this will be reversible. Now let us identify here different physical changes and chemical changes from the phenomena given below. Okay, so here I have made a chart of different phenomena and we have to identify which phenomena is will come under the physical change and which will come under the chemical change. Okay, so first is transformation of ice into water. Okay, so transformation, ice is a solid state. Okay, state of ice is solid and water. So solid can be converted into water and water again converted into solid. So this means this changes about the reversible. That means solid can be converted into water, water again can be we can convert water into solid form, that is ice form. So this type of a reversible change or temporary change, this will comes under physical change. Okay. Now next one is cooking of food. Okay. So here raw materials are there, like we want to cook the rice. Okay, so raw rice are converted into cooked one. So this cannot be reversible. Okay, that means cooked food cannot be converted into raw material, raw form. So this change is permanent or irreversible. So this comes under chemical change. Next is ripening of fruit. Okay, so again this cannot be converted back into the raw fruit. That means this change is permanent change, that comes under the chemical change. Next, again milk turned into curd. So student, this again milk turned into curd, but curd cannot turn again into the milk. So this is again a permanent kind of a change, which is irreversible change. Sorry, no, permanent not, this is a yes, this is permanent. So this again comes under the chemical change. Next phenomena is evaporation of water. Okay, so evaporation of water, this is a physical change. Next is digestion of a food in the stomach. So for the digestion of a food, when we take the food in, so what happened, different chemical processes are taken out just to digest the food. So this is again, this kind of changes permanent, which is irreversible. That means this is a digestion of a food is chemical phenomena. Okay. Seventh is size reduction, naphtha balls exposed to air. Okay, so this is okay. So the size reduction of naphtha balls exposed to air. So this naphtha balls we are using for the good smell in our houses. So this is what happened, only size reduction takes place, no chemical reaction happens here. So this is a physical change. Okay, now 8.1 is staining of shahbadi or kadpa tile by lemon juice. So lemon juice, we have citric acid is there. Okay, so this acid in lemon juice reacts with the tile and it makes the tile stain. So a reaction takes place. So this is a chemical change. Now 9th one is breaking of a glass object on falling from a height. Okay, here no reaction takes place. So again this will be a physical change. So I hope you all have understood how this phenomena we put into the physical change and chemical change. Okay, now let's just discuss briefly about a physical change. Okay, so physical change, just now we have discussed about this. It takes place due to the change in parameter such as temperature, okay, such as temperature and pressure. So when we increase or decrease these parameter, physical change happens, and this kind of change is what? It is a reversible kind of change. That means we can convert, like we will take here, we can take here example of an ice, right? That means the ice is transformed, this is ice is transformed into a water on heating. That means here we are increasing the temperature, here we are heating the ice and it will convert it into the water, and water is transformed again back into ice by cooling it. That means by increasing and decreasing, we are changing the state of matter of ice and water. Okay, and composition of matter remains the same over here. So this was about the physical change. Now let us discuss about the chemical change. Chemical change, composition of matter changes during a chemical reactions. Okay, composition of a matter changes during a process. So this is called as a what? A chemical change. Chemical change, and this kind of a change is irreversible. That means when a chemical reaction happens, we cannot convert it back into the original. And some chemical reactions are here taking place in the concerned matter. Okay, now what are the chemical reactions? A chemical reaction is a process in which some substances undergo bond breaking. Okay, so here it is a process in which some substances undergo a bond breaking and are transformed into a new substances. That means by breaking of a bond, new substances will be formed by formation of a new bond. So here bond breaking and bond making procedure is taking place. Here I have taken an example of a coal. It means coal contains a carbon. Okay, so in this kind of example, formation of a carbon dioxide, it takes place by combustion of a coal in air. Okay, coal react with the oxygen which is present in an air. So by combustion of coal, it react with the oxygen, and the product which takes place, it will be a carbon dioxide. Okay, carbon dioxide formula is CO2. So this is a chemical reaction, and in this reaction, coal which is there in a coal which contains carbon, it react with oxygen from air and are the reactant. So these two types, okay, these two types means oxygen, these two substances like coal and carbon and oxygen, these are called as a reactants. Okay, and a new substance which takes place, okay, new substances which form, it is called as a product. So, okay, so in chemical reaction, reactants are always written in left hand side, and product are always written on right hand side. Okay, so here the reactants will be carbon plus oxygen, it will form a new substances, that is called as a carbon dioxide. Okay, so this is a process in which a bond breaking will takes place in the reactant substances, a new bond forms in the product. A chemical reaction is represented by writing a chemical equation. It is represented by a chemical equation. So in this kind of example, okay, in this kind of example, here I have written carbon plus oxygen, it is converted into carbon dioxide. So this is a chemical equation. Okay. Alright, now let us discuss about the chemical equation. So here I have shown one activity. Here two beakers are there. In this beaker, in beaker 1, okay, in this is a reactant side, actually this is a reactant side and this is a product side. Alright, okay. So, in reactant side we have a beaker which contains a blue color solution of a copper sulphate. Okay. So, this blue color solution is just because of the copper sulphate in the beaker. Okay. And here I have a zinc particle or zinc dust. Alright, now what we have to do? We have just put this zinc dust particle into the copper sulphate solution. Okay, just we have to add this into copper sulphate solution. Okay, so by adding zinc into the copper sulphate solution, reaction will takes place. Okay, here one kind of a reaction will happen, and in next type of products beaker, in a beaker which is there, a product side, it will form a colorless solution. Okay, a colorless solution, and this is zinc particle. Okay, zinc particle which are in blackish color. Okay, zinc particle here grayish in color or silver in color. All right, but when they will react with the copper, what happens? They will turn into black color. Okay, it is just due to the deposition of a copper on the zinc metal. Okay, so here zinc is highly more reactive than the copper, that is why this reaction happens. And the solution, this is called as a colorless solution. This is a black colorless zinc sulphate solution. Okay, colorless zinc sulphate solution. Now let us write a chemical equation of this reaction. A simple way of representing a chemical reaction in word is called as a word equation. Okay, so this is a word equation. Now we will write a word equation of this reaction. Now let us write this. Okay. So first is aqueous solution. Okay, aqueous solution of a copper sulphate. Aqueous solution means what? That means a copper sulphate is dissolved in a water. Okay, so that is a aqueous solution of a copper sulphate. Aqueous solution of a copper sulphate. So this we are writing a word equation. Okay, plus next reactant we have is zinc dust. So instead of giving a arrow here, I am giving it downward because I don't have here place. Okay, so this is a reactant. So copper sulphate, aqueous solution of copper sulphate and zinc dust, these are the reactant, and when these two reactant mix together, what happen? A reaction takes place and the product we will get as colorless aqueous solution of a zinc sulphate. Okay, aqueous solution of a zinc sulphate plus copper. Okay, so here two reactant and two products are there, so that's why here we put a plus sign in between. So this is a word reaction of above reaction. Okay, now student, a word equation can be written in a further condensed form. Okay, so this is the word reaction and we have to condense this word reaction. So that is why we will write this reaction with a chemical formula. Now how to write this? Just look at here. Okay, so here I am writing this is a word equation. Okay, and now here I am writing a equation with a chemical formula. So here first is copper sulphate. Okay, copper sulphate formula is, chemical formula is CuSO4 plus zinc. Okay, so these are the reactant. A reaction will take place and they will form a product as zinc sulphate plus copper. Okay, so student, this is a word equation and this is a reaction with a what? This is a reaction with chemical formula. Okay, so these are the reactants on the left hand side and we have a product on the right hand side, and this equation with a chemical formula, it is called as a chemical reaction. Okay, this is a chemical reaction. So the representation of a chemical reaction in a condensed form using a chemical formula is called as a chemical equation. Okay, now we have seen how to write a chemical word equation and how to write a chemical equation with a molecular chemical formula. Okay, now let us understand what are the rules of writing chemical reaction. Okay, so first one is reactants on the left side and products on the right side, arrow between them. Okay, now here I am writing a reaction like just now I have discussed this. Okay, that means reactant like we have in this activity copper sulfate and zinc, and then zinc sulfate and copper. So the substances which I have written on the left side, these are called as a reactants, and the substances which are on the right side, these are the product, and there will be arrow between them just to show the direction of a reaction. Okay, just to indicate the direction of the reaction. So this was the first rule of writing a chemical reaction. Now second one is, if two or more reactants or products are present, they are separated by a plus sign. So here reactants also we have two reactants, okay, so and two products. So we will put plus sign in between the two reactants and product. Third one, mention physical states of reactant and product for just to make the reaction very or more informative. Okay, so in reaction we have a solid form. Okay, we have a solid reactant or product. So we will write S. Okay, we will write S, and if the reactant or product liquid, we will write L, just to know the physical state of the product and reactant. If the gas is forming in the reaction, we will write here G, small g, or we will put an arrow upwards. If the gas is formed, okay, we will write G or arrow in upward direction. But if the solid is produced, okay, solid is produced in the product, that means it is a precipitate form, and just to show the precipitate we will write PPT, or we can show also arrow in downward direction. Okay, and it substance dissolve in water, like just now we have seen aqueous solution of copper sulfate, aqueous solution of zinc sulfate. Okay, so just to show that the solution is in aqueous form, that means it is dissolved in water, we will write here AQ. Okay, that means aqueous. So here we have a reaction, just indicate the we will write here the physical state of this substances. So copper sulfate, this is a aqueous, so we will write here aqueous. Okay, zinc in solid particles, solid form, so S. Zinc sulfate, again this is aqueous solution, and copper, it is a solid form, so we will write here S. Okay, now fourth rule is, if heat is given from outside or released during the reaction, then how to indicate the sign that how to know that heat is providing from outside or heat is released during the reaction. So what happens if heat given out from if heat is given from outside? Okay, so here we will write on the arrow of the reaction, we will write the delta form. Okay, this is a delta, that it means that heat is providing or given from the outside to the reaction mixture. Okay, and next condition is heat is released. So when heat is released during the reaction, on the we will write heat, we will write plus heat with product. Okay, plus heat with the product. So these are the two rules. Now I am writing the reactions just to understand you. Okay, now first is calcium. Now first is a reaction, first is the example of this case. Okay, that means we are providing a heat to the reaction mixture, that is calcium carbonate, or we will also call this as limestone or calcium carbonate in solid form. Okay, so we are providing the heat, that means we will write the delta sign above the arrow of a reaction. Okay, it will form calcium oxide in solid form and carbon dioxide. So student, this is a carbon dioxide gas is there, so we will write arrow in upward direction. So this kind this indicates that heat is given from outside, we are providing a heat. Okay, now next example is of heat released during the reaction. Okay, so example of this is, again same example I am taking, copper sulfate plus zinc, copper sulfate in aqueous form, zinc in solid form, and zinc sulfate in aqueous form plus copper in solid form, and heat is produced. Okay, heat is produced during the reaction, that means here we will write plus heat towards the product side. Alright, now fifth one is mention certain specific conditions like temperature, pressure and catalyst, etc. So, if we are we are using the catalyst. What is the catalyst? It is the substance which used to speed up the reaction. Okay, so if we are using all this, we have to mention the conditions on the arrow. Okay, just to make it more informative. Like here, I am taking example of vegetable oil. Okay, vegetable oil in liquid form. So here I am writing L plus H2 gas. Here H2 gas is taken. So this is a hydrogenation kind of a reaction. We are using hydrogen. Okay, on the arrow it will now we will make, when we mix the vegetable oil with hydrogen, it will give the product as a vanaspati ghee. Okay, in solid form. So, we are writing here the parameters on the arrow. We are using the temperature, we are providing a temperature which is 60 degrees Celsius, and we are using the nickel catalyst. Okay, nickel is a metal, it is used as a catalyst to speed up the reaction, to speed up the hydrogenation reaction. Alright. Now, next rule is always write special information or name of reactant or product below their formula. Okay, now that means we will write the reactions, name of the reactant and product just below the chemical formula. Okay, first is reaction of a copper with concentrated nitric acid. Okay, so here nitric acid is there, but that is more concentrated. Okay, so just writing the reaction copper in solid form plus 4 HNO3. HNO3 is a nitric acid, aqueous form, arrow that means it will show the direction of a reaction. It will form a product as copper nitrate in aqueous form plus NO2 and water, nitrous oxide plus water. Sorry, this is nitrogen dioxide. Okay, so here I am writing nitric acid. Nitric acid, this is copper. You can write here the copper nitrate. Copper nitrate. This is nitrogen dioxide. Okay, so this reaction is with concentrated nitric acid, and for concentrated acid we can write here CONC also. That means this is a concentrated. Okay, and second is reaction of copper with dilute nitric acid. That means here more molecules of nitric acid will be present than the concentrated acid. Now, reaction we can write as 3 molecules of copper in solid form, 8 HNO3. Okay, this is a dilute. For dilute we can write DIL in aqueous form, arrow. Then again it will form a same product which is copper nitrate, but you can see the ratio of this. Okay, in concentrated nitric acid 1 molecule is formed, and in dilute nitric acid here 3 molecules of copper nitrate are formed, is in aqueous form plus nitrous oxide in gaseous form plus 4 H2O molecules in liquid form. Okay, so here you can, I hope you can write here the name of the reactant and product also. So, that is all for today.